Hello and welcome to this session about Eclipse Ankaios. So my name is Kaloyan Rusev, and today I'm going to show you the latest news and updates on our container orchestra, on our automotive orchestrator. All right, so yeah, Ankaios is a workload orchestrator where you normally need one server node to form the cluster itself, and you can dynamically then connect multiple agents to the server. So the agents under dynamic, you can understand that they can go, they can come and go to the system as they wish. So we want to have really high dynamics here and allow also turning off or on of ECUs at a certain point of time. The agents themselves, they have to be deployed on nodes which are either physical or a virtual. So it can be a virtual machine, a partition somewhere, or it can be a bare metal machine somewhere else. It can also be on the cloud if you want. It's not a problem. And when the cluster is formed, the server reads an initial startup configuration, which then is distributed to the agents so that they know what they have to start, which workloads. Afterwards, you can actually connect Ankaios to the cloud and start managing it from the cloud if you want. So you can actually have something like a fleet management system then deployed, which communicates with the instances of Ankaios that are deployed on the cars themselves. Because we also want to enable easy debugging, we have also written the Ank CLI application, which you can use for debugging sessions from either inside the vehicle or also outside of the vehicle, as long as you have a secure tunnel to the server itself. So that's it on the high-level perspective of Ankaios. And if we dive a bit deeper now into how things work, if we take a look now at the agents and how the agents execute things. So each agent can actually manage multiple runtimes, which are from a different type. So in this example here, we have a native and some containerized runtime. And I actually had a pretty nice animation here, which is not working. But the idea is that each workload is started depending on its dependencies. So if we have now, for example, a security application here, it's probably the most important one, which a lot of application has dependencies to. So it shall be started first, regardless if there is a health manager which depends on it on a different agent running on a different runtime. So the expectation here is that the dependency order of application is kept throughout the whole cluster. Another thing that we want to enable is that workloads can actually read out the state of the cluster. So if we have a health management application, as mentioned in the example before, it can read out the state, so which applications are currently running and which not, and can then dynamically update the state of the cluster during the running vehicle. So the health manager can then actually communicate through the server, which is not depicted here for simplicity, and then make the server start the others application, which is showing here. So everything here we have actually shown already, because we have already announced Ankaios on the last community day. And what's definitely the big news here this time is that we are now really public. So we have released our source code. You can use the QR code to go to our repository. It's under Eclipse Ankaios/Ankaios. And I warmly welcome you to go there, take a look in our documentation, to first to the README file, which actually leads you then to our documentation. We have a pretty comprehensive documentation, actually. This is just a screenshot of our installation page. So there is just a single command that you can copy-paste, and then you would have an instance of our Ankaios cluster running on your machine, including the CLI, and then you can start playing with it and seeing how the whole thing works. So you are warmly welcome to try it out. If you have some ideas, please write us an issue or write us on the emailing list. All right, and some other things that I wanted to talk about, which we have not spoken a lot about last time. We have mentioned already that we intend to have requirements tracing, but this is how it actually looks like. So on the upper left corner, you see there the page where we actually define our design, and there's a requirement up there. So this is the name of the requirement, and here should be the requirement ID actually, which takes care of the tracing towards code and then towards the test. So we have heard actually already a couple of times during the other sessions that there is this open fast trace tooling that can actually help you with the requirements tracing, and this is also what we are using inside Ankaios. The format which the open source tool is using actually comes originally from Elektrobit, and we're also using it internally. But the idea here is that you define an ID of the requirement, which is unfortunately not visible here, and then you tag source code and tests with this ID throughout your code, and the ID doesn't have to be some UUID that you cannot remember or something like this. We are always working with really normal plain text IDs that you can read and you can also understand what the thing is supposed to do. And Open Fast Trace actually at the end helps us to calculate out of this a requirements tracing report, which gives you the state of the requirement at the end. So this one here is covered. And it also gives you every place where this requirement is tagged inside the code. So at the end, when you make, for example, a build of Ankaios and you want to check something and there is a test failing somewhere, the benefit of the whole thing would be that if you are working on your product and you see directly that the whole chain from test code to the place where you actually defined what's supposed to happen. So you have a really nice way how you can actually go from failing tests or some bugs that you have found in your code to your definition of what was supposed to be the expected behavior and then trace down again. Another thing that we are doing is high quality. We're ensuring high quality via comprehensive testing. So we have unit tests where we have defined internally that we would like to have at least 80% of line coverage for us. The tests are nothing special, it's just the regular Rust unit test, so we are developing also in Rust. And we are using the mock-O framework to mock some parts of the code so we can really have pinpointed tests which just test the functionality at this exact place. What we are working on as we actually speak is also adding system tests to Ankaios, and we decided to use the robot framework for this. Probably some of you already know this framework and have used it already, but I can only recommend it on that place. So this is how the tests actually look with the robot framework, and if you check them out, just go to our repository. We are working on the changes. Probably they're even merged already. But the nice thing is that the system tests actually define plain text. So the robot framework allows you to define your preconditions, what should happen, and then the post conditions in a plain text manner. And this is then translated on the backend when you are executing the tests to Python code. You have to, of course, write some fixtures for this. But at the end, your test is also your test specification at the end. And this is also from a process perspective really nice because you don't have to prove that your test is really testing what your specification is doing. It's just the specification is your test. So it's really nice from that point of view. All right, and yeah, from the Outlook perspective, we have already released the version 0.1 on the 6th of September, so just a bit more than a month ago. And we are currently working on the version 0.2. The scope on the next release is to actually support K3S, or Kubernetes resources, manifests, which are then played via the Podman kube runtime that we are going to add now as a connection to Podman afterwards. So you would get support then for Kubernetes manifests. For version 3, 0.3, we are going to concentrate on dependency management. 0.4 will add authentication and authorization, so we're speaking about mutual authentication between the agent and the server. And also, as we mentioned, this health application, we want to enable all workloads actually that have sufficient privileges to also change the state of the cluster. And this authorization is coming then with the version 0.4. So thanks a lot. Do you have any questions?
I think I didn't really get it earlier. Maybe you mentioned it, but the framework for starting and managing the containers, is that Podman? What are you using currently?
Currently, we're using Podman, yes, but the idea is that we can actually plug in everything that we would like. So as you see here, the idea is to support multiple runtimes, and we're developing Ankaios in such a way that you can actually plug in your favorite runtime. Yeah. So this is also going to be on our agenda at some point to actually develop a runtime connector that can manage arbitrary runtimes, and then you can plug them in as executables. Yeah. Currently, they have to be built in the system, but it's really easy to build them in. So that's why the current milestone is 0.2. We are concentrating now on the Kubernetes manifest, but what we are also doing on the background is making it really easy to plug in your favorite runtime then in Ankaios. So you just have to write one code, which is kind of a binding to your runtime. It has to translate a couple of commands, so starting your workload, stopping it, stuff like this, and then you can just bind it to Ankaios.
Okay, thanks.